Hello, Absolute Madman here. Welcome to part 2 of my videos discussing the topic of estimating expressions upwards and downwards. On part 1, you were given 3 simple problems on the topic, and now I'll present you 2 more challenging ones. And I hope you're ready for the challenging estimating expression upwards and downwards problems. First, in problem number 4, you are asked to show that the absolute value of sine x plus cosine x is always less than or equal to square root of 2. Second, you are asked to solve the equation x to the 7th minus x to the 6th plus x to the 5th minus x to the 4th minus 4x to the 3rd plus 4x squared plus 5x minus 5 equals 0. If you want to try the problems now on your own, you can pause the video, or you can continue watching to see some hints. So in problem number 4, you are hinted to estimate the square of the original expression instead of the original one. It should be easier, and you can also get rid of the absolute value signed neatly this way. In problem number 5, you should by factoring or by guessing find all the solutions and then prove that the remaining polynomial has no zeros by estimating downwards to a certain number. You are also given some useful formulas to solve problems number 4 and 5. Try to use them effectively. If you want to now try the problems, you can pause the video, and when you're ready, keep watching to see some ways to solve the problems. And let's start from problem number 4. Here we have to prove that the absolute value of sine x plus cosine x is always less than or equal to the square root of 2. And if you know calculus, you can differentiate the function without the absolute values, of course, and looks for its maximum and minimum values and solve the problem that way. But in this video, I'm going to shift towards estimating expressions and using those little tricks. So I'm going to present a solution that doesn't use calculus. So what could we do to this expression? Well, one way would be, I even hinted at it, we could square it. And then this absolute value always has the value of what's inside it, or it's negative, and when it's squared, it gains the same value nevertheless. So we can actually write this as the square of just sine x plus cosine x. Because it could as well be the square of minus sine x minus cosine x, and that would be the same. And then how do we square this? Well, I had that one formula, a plus b squared equals a squared plus 2ab plus b squared. And we use that, and we just plug in a equals sine x and b equals cosine x. We get this. And now we see that there's sine squared x and cosine squared x. When we combine them, what did they equal? Take a look at them. We had a formula I hinted at, the fact that sine squared x plus cosine squared x equals 1. So we get this. And then we had the 2 sine x cosine x in our expression in the problem, and we are going to study this one. So we discovered that this is also sine x cosine x plus sine x cosine x, but I am for a specific reason going to write this way. I'm flipping the cosine and sine other way around in the second term. And what do we see now? Well, I hinted at that one formula, the formula of sine x plus y, and we discovered that this is like sine x cosine y, where y equals x, plus cosine y, where y equals x sine x. So we discover that this equals sine x plus x, which equals sine 2x. And now this 2 sine x cosine x, according to what I explained a bit earlier, equals sine 2x. So we get this. And now we know that sine 2x is always between -1 and 1. That is for all real x for the sine function. And for that reason we can estimate it upwards to be less than 1 plus 1, which equals 2. And of course this expression is always positive, so it's also greater than 0. And now we could take the square roots of both sides, since sine x plus cosine x absolute value is positive and 2 is positive, so we just take absolute values of, no, we take square roots of both sides and we get this. And that is what we wanted to prove. So we are ready with problem number 4. And in problem number 5, we had a polynomial equation and we had to find all real solutions for it. We had this, and now when we first look at it, could we factor out some terms? We can discover that actually we can factor out x minus 1 here. So we have x minus 1 times x to the 6th plus x minus 1 times x to the 4th minus x minus 1 times 4x to the 2th to the x to the 2nd power x squared plus 5x minus 1 equals 0. And we get this. So we have factored out 2 terms, and we could have also come to this result by just checking if one solves this equation and then come to the conclusion that yes, one solves the equation. And after that we would have known that it is divisible by x minus 1. But anyways, we get that either x equals 1 or this other expression equals 0 from the fact that either factor must equal 0 if the whole expression equals 0. And now we can underestimate this one to prove that this one has no solutions. How do we do that? This also means that x to the 6th power plus, I'll write this in parentheses just to make it clear, x to the 4th power minus 4x squared plus 4 plus 1 would equal 0. But why it is not possible? Because x to the power of 6, it's an even power of a real number that is always greater than 0. And this one is equal to x minus 2 squared. It can be given by the formula I hinted at, square of a binomial. And this is also greater than or equal to 0. And this is 1. So this whole expression is always greater than or equal to 1. So it can't be 0. So no solutions here. And that means our answer is x equals 1. And that is the only solution. Estimating expressions is an important math skill that just requires training. And if you want to develop it further, search the internet for cool math problems. Also search for my channel because I'll be posting more content online. And if you like this video, hit the like button. And if you want to see more math, subscribe to my channel. Thanks for watching and have a nice day.